Guys, how's it going? It's Ben from Check Tutors here, and today we're going to be covering the chemistry concept of the ideal gas law. So, in this video, we're going to define what the ideal gas law is, and then we're going to work through some example problems to familiarize you guys with using this equation and what the equation actually entails. So, the ideal gas law is illustrated here. You may have heard it before. The general saying is PV equals nRT. So what does each symbol mean? P is pressure, V is volume, N is the number of moles, R is your gas constant, and T is your temperature. So as the name implies, the ideal gas law can only be used for gases. And the ideal part of it comes from a few things that you have to know when using this equation. So first off, an ideal gas so this law is only for ideal gases. So ideal gases have a few important properties. The first one is that they're not real. It's ideal because they're perfect gases that don't exist in the real world. The second attribute is ideal gases, we ignore their volumes and masses of the gas particles. So it's as if they don't exist, but they do exist. So we're ignoring the volumes. And the third attribute that's important for ideal gases is that we ignore any intermolecular forces between the particles of gases. So we ignore any attraction or repulsion that the particles may have for each other. So if all of these are true, then we can say that we're working with an ideal gas. So it's important to, before you work on a problem assigned to you by a professor or teacher, make sure you read the question stem carefully and make sure that the ideal gas law is applicable to your current situation. If they say that, yeah, assume that it's an ideal gas you're working with, then yeah, go for it. You can use this equation. Okay, so let's get some actual experience using this equation under our belts, shall we? So the R is probably the most confusing part of this equation. It's a gas constant, which means it's always the same. There are multiple R's you can choose from, and depending on which R you choose, that's going to determine the units for the rest of your values. Because, okay, so excluding temperature and moles, moles are always going to be in moles. I mean, you may have like micromoles, but they're always going to be in moles. And temperature is always going to be in Kelvin. As for pressure and volume, there are different units associated with pressure and volume. For example, pressure you can use atmosphere or millimeters of mercury, or there are a lot of other units. And for volume you can use liters, milliliters, etc. So whatever R you choose is going to determine which units that you're going to use for the rest of your values. So a common R to use is this one. It's 0.0821, and the units is going to be in atmosphere, liters over moles, Kelvin. And the purpose of the arrangement of these units for the gas constant is to cancel out the respective units on both sides of the equation, and you'll see that once we work out a problem in just 1 second. So those are the values of the equation. So let's get to an example problem. Let's say that we have a cylinder, and inside we have H2 gas, or hydrogen gas. And this is going to be a multi-step problem. We're going to have to perform a step before we actually use the equation, but it's fine. I'll walk you guys through it. It should make sense. So let's say that the pressure inside this cylinder of hydrogen gas, remember that the hydrogen gas is H2 and not just H. Let's say the pressure is 2 atmospheres in there. Let's say the volume that is determined by the cylinder itself is 4 liters. So pressure equals 2 atmospheres, volume equals 4 liters. And let's say that the problem also gives you that the weight, or the mass of the gas is going to be, let's say, 4 grams. And they're asking you, what is the temperature? What is the temperature of this gas inside the cylinder? So at first, it seems that we don't have all the pieces that we need. recall, based on basic algebra, that in order to solve for an unknown, all the other parts have to be known. So we have our pressure and our volume, but this mass is weird because it's not even part of our equation. Well, if you recall, for every molecular substance, you can relate the number of moles and the mass using the molar mass. So the molar mass of our hydrogen gas is just going to be, molar mass of your H2 is going to be around 2 grams per mole. So we can use this to convert the number of grams we have to the number of moles. So if we have 4 grams and it's 2 grams per mole, we can use an easy conversion, and we see that we have 2 moles. 2 moles of gas, 2 moles of our hydrogen gas in there. So this is our first step. Before we even use this equation, we have to convert our mass that we're given of our hydrogen gas into a usable thing for our equation, in this case moles. So we divide the mass by the molar mass to get the moles. So now this question becomes pretty easy. We look at our units, we see that we have atmospheres, liters, and moles, and we're looking for temperature in Kelvin, so we're going to use our previous gas constant of 0.0821, and now we can set up our equation. So our pressure, 2 atmospheres, times our volume of 4 liters, is going to equal our number of moles, which is 2, times our gas constant of 0.0821, atmospheres times liters over moles times Kelvin, and then our T. So if we want to solve for our T, we move to one side, we move everything else to the other side. 821 atmosphere liters over mole Kelvin over 2 atmospheres and 4 liters. So now it should become obvious why the units of the gas constant are as they are. They're set up in a way so that they'll cancel when you're solving for one unknown of your gas, whether it's pressure, volume, number of moles, or temperature, which is usually going to be what your professor will give you as a problem. He's going to give you all the necessary information, and he's going to ask you to solve for one unknown. So in this case, the units of the gas constant are set up in a way that the units cancel until all you're left with is what you're looking for. So if you look at here, we're going to multiply by moles, so that's going to cancel out the moles on the bottom over here, and then we're going to divide by the atmosphere and liters, so it's going to cancel out the atmosphere and liters over here, and what we're going to be left with is this Kelvin, and that's what we're going to be looking for, except it's going to be, in this case, 1 over Kelvin, and oh, that's because I put the wrong things on the wrong side. So don't do what I do and don't move the wrong things to the wrong side. So in this case I should have moved this over here, but I did the opposite. So we can solve this by saying that this all equals 1 over t. Or, you know what, I'll just redraw it. I'll say that t equals, so we move this over here, so this is going to be on top. So 2 atmospheres times your 4 liters over 2 moles times your gas constant of 0.0821 atmosphere liters over moles Kelvin. Okay, so now it should make more sense. So now, once again, your atmospheres here, and your liters are going to cancel out with the ones over here. You're multiplying by moles over here, and you're going to be left with kelvins in the bottom, but because we're dividing, they're going to be flipped up top, and you're going to be left with Kelvin as the final unit for the temperature. So yeah, that's why the units of the gas constant are as they are, so that you'll get the units you want for your final value. So now all we have to do is the math. So these 2's cancel out on the top and bottom, so we're going to be left with the temperature is equal to this 4 divided by your gas constant. So we'll use the calculator. 4 divided by 0.0821, and you get a temperature of 48.72 around. So we're going to ignore like proper sig figs and all that for this problem. So 48.72, remember that unit is Kelvin, never answer in Celsius or Fahrenheit. And Kelvin is our unit that we're left with after all the other units are cancelled out from our gas constant. So your final answer would be 48.72 degrees Kelvin. And that's how you use the ideal gas law to calculate for a certain unknown given all the other information. So remember, before finishing this video, remember that this can only be used for ideal gases, so always remember to read the questions then. Okay, so hopefully you feel more confident about using this equation now. Remember to always identify which unknown you're solving for. And remember that the information they give you is not always going to be immediately able to be plugged into the equation. You may have to manipulate some of the information, like we did for this problem where we changed the mass into a mole value. Okay, so that's working with the ideal gas equation. Hope you guys understand.